everybody. Let's begin. Once again, I would like to introduce myself. I'm Verbitsky Igor, and Aleksandr Rakhmanny is with me. And we're going to tell you how did we approach question of security of container infrastructure, what we've been looking, what conclusions did we come to, and what pathway did we go. In the beginning, please remember what could be the typical ways of developing infrastructural companies and what are the peculiarities thereof. In the beginning, as usual, they use so-called iron infrastructure, hardware infrastructure. What does it mean? Services are located on physical servers. There's operation system, and there's also a service where it is located. It could be one server, one service, and on one server there could be several applications. The next stage of development is virtualization. Virtualization allows us to emulate operating system. We have in our infrastructure a new layer, hypervisor, which manages guest operating systems. This approach is very similar to our hardware infrastructure because it has emulation of the hardware. And the next level that we have is the containerization. These are microservice infrastructure. Peculiarity is that we have a new layer of the containerization environment which emulates operating system. And services are launched in containers and not in the operating system. What are the advantages of the containerization to our point of view for the DevOps team or for the development team? We have pointed out the key advantages. We are not speaking about all the advantages. The first one is that we need less resources to deploy our services because in the framework of our hardware server or virtual machine in the cloud, you can deploy several microservices. The next advantage is the speed and scalability. Deployment of the container infrastructure, relatively speaking, can be done in a couple of commands in console, and you can do it, and you have a complete service infrastructure which is functioning on the full scale. And the next key advantage is that you can reuse the environment of containerization is actively used right now, and many vendors in their packages are using complete images for the deployment and containerization thereof. You get the distributive, you start container in your machine, everything is pre-installed and tuned. However, these are advantages for the development and DevOps, but there are certain peculiarities, as we call it, for the security teams. Once again, we have separated three key peculiarities, which to our point of view are very important. The first one is that containerization, as I've told you previously, is another technology in relation to classical infrastructure because we don't have a hardware emulation, we have personal system emulation, and this is a totally different approach. The second one is that in a short period of time, in a very short period of time, you in your infrastructure might have very big amount of vulnerable services because the launch of container, as I've told you, takes approximately a couple of commands. If you have several commands, several development team use containerization, then in this short period of time, you will be able to receive a very poisoned infrastructure. And then another disadvantage that I was speaking about compared to pluses is that you can use containers of other vendors, other teams, and as a rule, not all the developers and DevOps teams analyze what is located inside of these containers from the point of view of the code base and also from the point of view of some dependencies and vulnerabilities of the libraries. This can lead you to the situation that somebody else's images can bring to vulnerabilities, which will become your problems, the problems for the security teams. Okay, let's speak right now how it was before from the point of view of protection of the infrastructure and what to our point of view has to be done. What else? And which mechanisms were used? Well, in the beginning, this is segmentation, separation of various environments, development environment, testing, production, separation between services, separation between teams, maximal segmentation inside of the infrastructure. Also, we are using the system for traffic analysis, ATS-D system, so we can use different scanners for scanning the infrastructure, which allow us to search vulnerabilities in operating systems and in applications. We also can use class of solutions which provides protection of the classical devices, and access rights can be managed. These are the main mechanisms which are used for the protection of classical infrastructure. But containerization has a peculiarity, and let's speak what has to be introduced to the containerization system. The first thing, because we're using images, we should scan those images for the availability of vulnerabilities. Also, in the image, we can have libraries which are getting connected, and during the presentation, during the conference, people have been speaking a lot that dependent libraries can contain vulnerabilities, and we have to pay attention to all of them. So we would like to look at what do we have with those tickets which are connected from the point of view of containerization. Also, when we make those images, some developers or DevOps teams, they may forget and hard-code some secrets in containers. If this container is stored inside of the internal repository, it's half a problem, but if not, this also can lead to a big incident when secrets will be leaked outside. So you also have to look at them. And because containers are launched in the environment of containerization, it also has its own settings, it also has security mechanisms, and you have to look at what happens with the containerization environment, because if the containers are protected and they have no vulnerabilities and the environment is not properly tuned, the attack can go through it. Also, please don't forget about different malwares. You have to look at containers, at the availability of vulnerabilities and malware inside of them, so this protected container would not get into our infrastructure. The problem is understandable. We have looked at all of this, we thought about all of this. Well, it's understandable that something is to be done with it, and we decided to look at what is available from the point of view of enterprise products and paid solutions. What can help us to solve this problem, and can it help us? We went to the market, we looked at the market, and I would like to tell you about two products to which we've paid a lot of attention. The first of them, it's a well-known product by Akka Security Company, long time in the market, many people heard about it, pretty cool tool. We've looked at it, we tested it, and I've separated some advantages that we have looked at for ourselves, because this product supports integration with many CI/CD systems, and it allows to scan containers for vulnerable code. It searches for secrets, for different vulnerabilities. It has a mechanism of a sandbox which allows to analyze all of these. Also, this tool allows to scan containerization environment for the compliance to the best practices, to look what is good and what is bad, and terraforms. The advantage of this product is that in addition to containers which are being deployed in the containerization environment, it can also look at what really happens in the containerization environment and block these or those containers according to those rules that you will develop. But this tool has advantage and has disadvantage. The key disadvantages that we've had, the first one is that it supports not all the versions of Kubernetes. The minimal version from which it works stably, it's 1.18. And we are using multiplicity of containerization environments. Not all of them are compliant to minimal demo versions. And I think this problem is available inside of many companies. And during the development of this tool, we would like to cover the whole environment of containerization so that we wouldn't have any environments which are not being analyzed by these mechanisms that we are planning to mitigate. The next risk, which is very important, it's a not domestic vendor. It is possible to buy this license, but nobody gives you the guarantee that this possibility will stay with you in a week, month, or a year, because experience shows that even those vendors who initially have told us that they are staying in the market and they are working, but then under the pressure, they change their policies. And the final disadvantage is the cost, because the import substitution has been evaluated as a IL-86. Well, the product is very expensive, and these are expenses if you don't understand why do you need this product, or you have a small infrastructure. Then, to our point of view, buying and implementing it at first stages may be not expedient. Well, we've looked at foreign solutions, and then we moved into domestic solutions and a product from the side of Kaspersky. It was also very interesting. We've been meeting guys, so we've been looking and separating the following advantages. The first one, we have integration with many CI/CD systems. The tool checks containers for vulnerabilities. From the interesting part, in addition to the fact that they also evaluate the PPDU. It's important for state public companies. Also, they control the settings of containerization environment. They check containers for a vulnerable and malicious code and net interrelations in the environment of containerization. Also, they have very good monitoring of these consumed resources. And to our point of view, it's a pretty good product, but out of disadvantages that we have pointed out for ourselves, the minimal version should not be less than 1.18. And to our objective point of view, we have figured out that the product is not really ideal right now compared to security. But what makes us happy that there is a domestic solution, and our guys have the vector of development, and the product by itself is pretty cool. When we looked at the enterprise solutions, we decided to look at what do we have in the open source, and do we have any good products out there, and can we figure out something for ourselves. We've looked at a lot of different things. On the next slide, we decided to show several products out of what we've been looking at. And in this spreadsheet, you see some criteria on the basis of which we've been assessing these products. Out of the main ones, we can Crib and Trivia. These two open source products are free engines from commercial projects as Encore and EcoSecurity. That's why they show pretty good results. We also looked at something like Docker Scout. Not really a good one, because many things that we wanted to do, it doesn't do, and because we are using as infrastructure, we use Yandex Cloud. We also looked at the product from Yandex. At that moment of time when we've been testing it, it was in at the initial stage of development. I know that guys are working on its improvement, and maybe at the current moment of time it gives better results, but at that moment of time it was really raw. We looked at enterprise, we looked at open source, we came to certain conclusions, and we have understood that unfortunately nothing works for us. So that product will solve all the problems that we want to get to solve. So what conclusions did we come to? What do we want from this scanner? The first thing, it has to check our containers on different stages. So what are those stages? When containers are in repositories, when it goes through the process of assembly of CI/CD, and when it is in the runtime in the system of containerization. The next thing that we want our container to be checked for the availability of different vulnerabilities, the container and the libraries, and also it has to be checked for the availability of the malicious malware load. Also, we've been speaking about the containerization environment. We would like to see that it has to comply to the best practices, and our tool should allow us to check these policies in the environment of containerization. Because the analysis is very good from the point of view of technical approach, these results also has to be reflected somewhere. We have to look at it and correlate it. That's why we would like for our tool to allow us to conveniently work from the point of view of visualization of the data. And because we are a company, Lamoda Tech, we're a technical company, we want this tool to be written with good creative approach, with using good stack of technologies, and we use local. We wanted to do something with clouds as well. What's next? Well, the classical stage of denial, then trading, wrath, depression, and the final one is acceptance. However, but no, everything was totally different. After we have looked at the market, we have looked at the criteria that we would like to apply to our tools. And we've made a certain concept. How do we see it? We have evaluated our expertise. Do we want to do it or not? And we decided that we can do it. We have understood that this is good from the resource point of view, and we started developing this service. And of course, we want to show you what do we have under the hood from the technical point of view. And right now, I would like to give floor to Sasha, and he's going to tell you.
Первым делом нам нужно было ответить для себя, где и когда мы будем сканировать.
We had to give answer to ourselves where and what is going to be scanned.
На этапе сборки контейнеров в нашей CI/CD. Тут мы можем...
On the stage of assembly of containers in CI/CD, we can stop the assembly pipeline if we find a critical vulnerability here. But we have faced the situation that not all containers are being assembled in GitLab. The second one, when the new image is put in a corporate repository, we can scan here before deployment into production, and then we can prohibit deployment of the vulnerable artifact. But the problem is that we don't have information about actuality of the image, and it's not going to happen in Kubernetes. Maybe someday. The third option is a new image in the execution environment. We can scan actual images and those applications which are working in prod, in pre-prod, in QA environments, and we can prohibit deployment and work of vulnerable code through the mechanisms of mission control. But the problem is that container will already be in the execution environment on the stage of scanning. And there's another option when we can scan. It's periodic scanning, and we can discover new vulnerabilities in old images. Yes. So let's speak, how did we do those integration? Integration number one is the GitLab CI. We have collected and assembled our own container for scanning, and we have added it to the pipeline of assembly with the next step of assembling the main image. And after the results of this scanning, we are publishing these results in CI. Then we have added a service which receives information about the beginning of scanning. Then we get a raw data from scanner. We form objective for normalization of this data. Also, we have put a possibility of assessment of vulnerability of critical data for us.
По модели Quality Gate и сможем останавливать...
On Quality Gate model, and we can stop pipeline in the future and the work of the future pipeline if we find critical vulnerability. The second integration is integration with repository. We use artifacts. We set up the sending webhooks when they appear new image in the repository. In API service, we have the reception of these hooks and putting it in the queue for scanning. Then a pool of workers takes objectives from the queue, do the scanning, and the results are stored in S3 repository. We also make an objectives into the queue of data normalization. Integration number three is integration with Kubernetes cluster. We have developed a planner which is getting connected to Kubernetes clusters and requests new codes and containers related from the moment of last syncing. And we check, have we scanned the images of containers previously? Also, we formed the list of images that were scanned more than 30 days ago.
Дальше планировщик формирует список задач.
Also, the planner forms the list of objectives for scanning and sends them to the queue, and as a worker does the scanning and sends results on.
Мы собрали все три интеграции.
After this, we have assembled all three integrations together, and what did we get? At the first stage of assembly, we check the image for vulnerability, and in the database, we record the results of the scanning and its hash. After this, we're transferring the image of corporate repository, and also we're transferring the repository images from external repositories. Artifacts are sent webhook to our service, and we are checking through hashes, have we scanned this image of container or not. Then deployment is happening in the execution environment. We deploy the applications and we connect through Kubernetes. Have we scanned these images previously? If they have not been scanned due to some reasons, we do the scanning. So what was the architecture in the result? Planner and API services give an objective. Workers do the scanning and send all this information to normalizer. But why do we need normalizer? Because we have faced the situation situation that some CMs are not able to properly parse the information from our scanners. That's why we've made a separate component which prepares special image-related information and sends it to visualizers and databases get only general statistical information. And the most interesting question is what is under the hood of our scanner. We have a controller which receives objectives from the queue or from the CI. And after this, consequentially starts 3 scanners. 3V for scanning for vulnerabilities, secrets, and errors in configuration. Gripe scans only for vulnerabilities, and Kaspersky endpoint protection scans for malware. Which visualizers do we work with? The first one, Defect Dojo. It's open source visualizer of vulnerabilities. It's out of the box, supports results, raw data, and Strivia and Gripe. We transfer information for Max Patrol, CM, and Wazoo. We have to normalize this data. Divide results of the output of our scanners into separate events and enrich image-related information given to scanner. What advantages did we get using distributed architecture? First is scaling. Thanks for the queues, we were able to flexibly scale the number of scanners and parsers, and then we dynamically can change their number on the basis of the size of the queue. The second one is consistency. The queue is responsible for the consistency of data. If during the scanning we have a critical error on one of the nodes, the objective will come back to the queue and it will be processed by another node. The third one is flexibility. The fact that we have separate parsing, separate scanning, we can add another scanning engine, or we can add another integration of visualization without changing the whole architecture in total. Since the beginning of the development, we decided to use cloud technologies. We are using Yandex Locker. What did it give us? First of all, it's speed up of the deployment. Deploy the resources in the cloud. It's fast and not really expensive. An advantage for the Yandex, they have non-tarified limits. The first 100,000 requests in the Yandex queue are free of charge. The second one is the reduction of the expenses for the support. Care about high availability, reserve copying. We put it on the cloud engineers with good SLA. And then we pay as we go for what we use. Many Yandex resources are not tarified if you are not going to them. And by this, we are reducing costs to our infrastructure. So which technologies do we use right now, and how could we replace it if we would deploy our solution in the on-prem? The first one is Yandex Cloud. We put queues for normalization for scanning locally. We could use Kafka or RabbitMQ. The second one for storage of raw and normalized data, we're using Yandex buckets. But we would use any network storage. The third one, we use Yandex MDB. It's a managed database where we store the history of scanning, the content of Kubernetes clusters, and we could replace any database, Postgre, MySQL, and by any others. And we are launching our scanner nodes in virtual Yandex machines. They are working as Docker containers, and through API of Yandex, we can manage these virtual machines. If we have a queue of scanning, if it's empty, we disconnect all virtual machines where the scanner nodes are working. If you have new objectives in the queue, we launch virtual machines, and after this, we check it. Do we have it properly operating? Have we launched all our containers? We also have a small video. We can show you how all this looks like. We took a test repository from Microsoft. This is a simple microservice eShop, just to show you how we will assemble and show the vulnerabilities. We will clone it. We will add instruction for assembly in a standard way. 2 steps. The first one, assembly of our application. The second one, copying into runtime. Runtime, we use ASP.NET 8.0. Right, pipeline of assembly is being written 2 steps. The first one, we assembly 2 of our microservices, and the second step, we are scanning them and transfer them into CI, our container. As you can see it, this is something that has to be scanned by it. Then we send changes into master. We see what happens with the assembly and scanning.
На примере мы покажем, как выглядит это все.
On this example, we would like to show you how it looks in defect dodge. You see that on the main page, or you see the number of vulnerabilities. There are types. You can look at vulnerable components which are available and the number of vulnerabilities inside of them. If you will enter any component, you can look at which vulnerabilities are available inside of this component.
В метриках мы можем посмотреть, сколько у нас.
In matrices, you can look at how many we have opened and closed vulnerabilities, vulnerabilities by types, timelines, days, weeks, types of scanners, types of vulnerabilities.
И также можем посмотреть вообще все.
And you can also see all the vulnerabilities in this particular image.
В каждую уязвимость.
You can enter every vulnerability. You can look at its assessment vector, when it was discovered, its description, URLs to documentation where you can read about this vulnerability.
Немного изменим базовый образ вместо.
We change the basic image instead of ASP.NET. You can use outline. It's a simplified image which doesn't have a lot of components with vulnerabilities. Also, we will send all of this to master, and then we will wait to the end of assembly and scanning.
Defect dodge, мы видим, что у нас осталось всего.
Dodge defect, we can see that we have only 2 vulnerabilities left with low assessment.
В вкладке, точнее, в колонке актив показывается, что.
And in the active column, you can see that inside of these components there are no active vulnerabilities, and the whole history is shown with the status mitigated and inactive. So previously they were available, but we have fixed them by the update of the basic image.
В метриках мы видим, что у нас все, которые там.
In matrices, we see that all vulnerabilities have been closed, and we see the graph daily that everything dropped down to zeros. And by types, we also have less of them, and 2 active components, 2 active vulnerabilities with a status low. You can see all the information here, in which version it has been fixed.
За демо. Хотелось бы подвести некий итог, что в итоге.
So I would like to summarize what happened upon the results of our development. We have received the service which allows to serve those tasks that we have ahead of ourselves. We have received a tool which allows us to give results in sub-universal format, which allows us to transfer different visualizers. Like Sasha said, 3 products we have shown you. These are 3 products on which we have tested that it works, and results are being transferred. And we can build dashboards or correlational rules if we speak about CM, but it's not going to be difficult to use some other systems of visualization, because in principle they have typed information. We have received a tool which can flexibly be scaled, because the infrastructure of these services is separated into components, and you can connect different sources and tools and engines for scanning in addition to those which are used right now, and you can do it very flexibly. And finally you have received that tool which gives you the quantitative assessment of to our container infrastructure. We're not speaking about things like a process, what is to be done with it afterwards, and how we can build relations with the development teams, DevOps, because it's a separate topic of presentation. But we would like to show you how, and with the help of what, can we measure the safety of your infrastructure, how this can be done. We have shown those tools on the basis of which we have done it. We created examples which on-prem stack technologies can be used for doing that, and we wanted to repeat this path. And here's a small timeline during which period of time we have been able to do it. In the Q3 2023, we have started testing, we have looked, researched, and made a certain concept, and in the 2 quarters we have developed this tool and implemented into production. And I would like to point out that all this activity was not the main work, meaning that me and Sasha, both of us, have been realizing this particular tool. And in addition to the fact that we've been developing this service, we also have we had our own operational work. So this was like a backup work. And by saying this, I would like to tell you, if we would be involved just in pure development and if we would have a bigger team, this solution could be created very fast and flexibly. Also, what helped us is that we used cloud technologies, which allow us to deploy these services very fast. Thank you for coming and listening to us. Thanks for Sasha's work, for participation in this project. And on the final slide, you can find our contacts. We're going to be here in this tent. You can ask questions to us personally. You can write to us in Telegram if it's going to be interesting. And there's a QR code, please. If it's not complicated, please give evaluation and feedback to our presentation, and we are ready to answer your questions right now.
Спасибо, ребят. Переходим к секции ответов.
Thank you very much. Let's go to Q&A session. I would like to remind you that upon the results, you will have to select the best questions, so please remember them. Q1, what is wrong with Strava? Why didn't it work for you? Because even in your slide and your columns, and why your product is better than Trivia? Trivia.
Коротко, да, тут комментарий поступил. Почему не 3?
Well, briefly, there was a comment. Why not 3? We decided to use several scanners to cover the maximal possibility and not just one specific scanner. Thank you very much. Can you explain why the support of Kuber 118 is the minus, and when it achieved end of life in 2021, it's a minus of the infrastructure of the business, and looking at the older version is not expedient? I don't think it a disadvantage the absence of support, and on slides we've been showing you that current enterprise products security from Kaspersky says that they function very well on version 118 and older. The fact that somebody have versions lower, it's normal. And in some environments, in some teams, we do have it. It's life, it happens. It's not good, not bad, it's just there's a scenario where we use it versions even after the end of life. So if you have such versions of Kubernetes, and if you want to look at the price, you don't have to, because they're guaranteed they are not going to work on these versions of Kubernetes. So it's a question which is related that you also have addition to the security risks, and why it would be more beneficial to update Kuber and use the end solution. Why the Kuber is not being updated? It's not everywhere it's possible. We wanted not to have this version, but we still have some teams who use it, and our main objective was to cover it together with all of our people.
Скажите, оправдались ли временные финансовые затраты
Tell me, please,
решения при условии...
the financial expenses, have they been covered because you still use open source under your hood? Yes, we get our payback. And on the last slide, I've been showing you the scale. How long did it take us? 2 quarters. It's not too much. If we wanted to make it much faster, it means we would be able to do it. These are not so expensive compared to enterprise products. Thank you. Next question. How many man hours went to develop the solutions?
Не полный рабочий день, если так смотреть.
Not full work day.
4 месяца.
Well, I'll take 3-4 months of a developer. Thank you. Tell me, please, about the criteria for quality gate settings. Yes, we have defined it.
как раз вот эту оценку.
We're going to develop this assessment. It's available in the code, but it doesn't work yet.
Расскажите, с какими
It's not implemented. Tell us, please, which difficulties you faced while developing and what initial solution would you change right now?
Трудности это, наверное, были.
Difficulties were
Сделали
such that we've created a scanner when we wanted to do it, when we wanted to give results to CM, and CM didn't understand Max Patrol and Vazoo. And we had to create normalizer which would prepare the data and would discover changed fields and things like that. For the normalization, for the proper parsing with these CM tools, what we would apply, we would keep it like that. We like the fact that we set it to CM because we can flexibly build reports and graphs rather than in Defect Dodger. They have only those panels which out of the box, and you wouldn't be able to add your own. Thank you. Wouldn't you look at the possibility of launching a scanner Kubernetes right time through the job? In Kubernetes, we did look at this opportunity, but why didn't we do it in product? Because a big load against hard drives. So we didn't want to affect our production. It was the same trivia operator that is inbuilt in Kuber. But then we put all the remaining infrastructure in the virtual machines. So if right now we have nothing to build, we have nothing to scan, through the API, the whole infrastructure is switched off, and we are storing only for the storage, without operating memory, without central CPU. This is not just to save money. Thank you. Where's the guarantee that a developer is not going to lose a CI/CD scanning stage? In our pipeline, there's a definite condition, and DevOps colleagues do it, that they always, after the assembly, should have a scanning stage. So when developer adds his own pipeline, it's not a separable operation, assembly and scanning. Thank you. How do you solve the problem of deduplication of findings in Defect Dodger? Let's say Defect Dodger, we're not using it almost right now. We have not faced in our problems. And we understand that these results can be downloaded and they are working. So we don't give anything to CM because we want to see certain dynamics of the picture so that we can use this information correlation rights. How do you realize scanning, authentication, encoding? Are there risks of substituting data after scanning? If yes, which measures have been taken from this point of view? Yes, Yandex Queues supports authentication when you get connected, login password or a secret key, I don't remember exactly. And yes, there is authentication, but in the queue we have only that information about ID of scanning and the name of container that has to be scanned, or the image that has to be scanned. And no detailed, all the sensitive information is not there. It's saved in S3 bucket, and they use authentication as well on the level of Yandex and service accounts. Is it sufficient to have scanning to say that container is safe? Perhaps not. Not sufficient. Before, after scanning, the container can be launched and changed in the runtime, and we've been thinking about it. How can we research this topic and how the container can be changed? We did not come to a specific solution yet. Right now, we are working on different possibilities, and one of them is to install our agent on Kubernetes nodes and scan whatever works right now. Thank you. How can you change security, safety of access to containers?
Я не совсем понимаю, как этот вопрос
I
относится.
don't understand how this question is related to the current tool.
Автор здесь, давайте встретимся.
But maybe if the author is here, let's meet outside and talk
Сколько
about it.
обычно времени тратится на
How much time is spent for scanning of container by your method?
Небольшие контейнеры.
Everything depends on the container. Small containers can be scanned within 1-2 minutes, but we have big containers with a size 4, 5, 6 gigs, sometimes 50, 20, 30.
Это был контейнер из 20
The
гиг.
biggest container we've scanned, it was a 20 gigabytes container, and it took us 45.2 hours.
Вот это время сканирования.
In order to minimize the scanning time, as Sasha was telling you,
Этой проблемой, когда
we have faced this problem as well when we started scanning, and we have understood that some containers are being rescanned, and for this we use SHA-156. We take the hash from container, and if we do see that this container already appears with some artifact in CI/CD or in runtime, and we understand that we have scanned it, so the time for rescanning is not spent, understanding that its condition is consistent, we've scanned it, and it allows us summary time for scanning of all the stages and repositories have been reduced significantly. The next one is a big question.
внутри докер-контейнера может быть
Description. Inside of the Docker container, they can launch a third-party application through the docker-et command.
команда ls или по
Can you launch container with nginx-ls or raise it from ls server? Did you look at the behavior of containers possibility? Did you launch monitoring of the container application, detecting of anomaly activity inside of the container and transferring logs to CM?
это вопрос не в рамках.
This is a question not in the framework of this part of presentation. Paid solution security-wise allows you to monitor runtime on the level of a networking cooperation between containers, and our solution is not covering this part. These things are solved by some other tools like segmentation, like IPS-IDS and logging activity. So specifically on the containers, we don't use it or inside of computer. But with compensating measures, we are closing these vulnerabilities.
Как вы
Thank you.
минимизируете false positive и срабатывание на open source компонент?
How do you minimize false positives while working on third-party components? It's a process question. We are still working on this, and we don't have a silver bullet to solve this problem. Yes, we're building this process so that working on false positives. And the second part from the second viewer.
Базовых контейнеров
How do you discover vulnerabilities in basic containers from which the assembly of other containers happens? And do you have the exception of discovered vulnerabilities from the basic containers?
Так,
как обрабатываете ли вы по особенному базу?
Do you process them separately,
мы
those
сами
basic
базовые
containers?
контейнеры не сканируем,
No.
мы сканируем то, что получилось.
Basic containers are not scanned.
Базовые
We are scanning what we have in result,
одной уязвимости
because the
на этапе
basic
сборки
container may have no vulnerabilities, and the level of assembly
компонентов еще
to apt-get.
базовый контейнер мы никогда не трогаем, мы сканируем всегда финальный.
We scan the final container usually,
Ответили?
not the basic one. Did we answer your question?
Планируете ли вы пойти с продуктом в коммерческое?
Do you plan to go with the product to the commercial field and maybe place yourself on the shelf of the cloud provider? Good question.
Обсуждается. Пойдем ли
We are discussing these questions. Will we go in this direction or not? I cannot give you the answer right now, but we are thinking about it to somehow moving into the commercialization, maybe
Яндекса? Ну,
through the marketplace in Yandex or cloud providers.
Проверку самих open source.
Did you check the open source scanners for vulnerabilities, or you
Секретов в себе.
not declared, for example, sending your secrets to your own server?
Ну, насчет отправки у нас
Well, about this sending,
они не могут отправиться, у нас
they cannot be sent
запрещают отправку.
because we have networking rules which prohibit sending to anywhere. It
Один внутренний.
permits only the update to one internal service,
То есть
the
отправка
database update.
наружу у нас из
So the secrets are not sold outside.
Ждал? Я надеялся, что
It's a good question.
open source.
I wanted somebody to ask it. Open source is some painful topic.
Доверять, не
I
доверять.
will do 2 more times. Well, trust or not to trust. Well, there's enterprise and open source. Of course, in open source, different people can contribute, and there could be different cases. A couple of years ago, when a certain event happened, when they've been adding some code which was doing something bad, or visually done something good, or maybe some inbuilds were happening. And in our product, we're using a well-known engine, and to our point of view, they are under the analysis of the community. And if something like that is going to happen, people will start talking about it very loudly. That's number one. And number two, what Sasha said, on level of segmentation of access, external infrastructures are analyzed and segmented. And the third one, nobody tells you that this security does not contain this information. Maybe nobody is checking it. Okay, thank you. Why do you need Vazuk in this scheme? Vazuk was shown as an example of open source CM platform solution. So if you want to repeat our experience, you can use it and deploy it. But its advantage is that it allows you to visualize data, build diagrams, dashboards, and look at them. And second of all, it allows you to use these data for correlations and for analysis. But most likely it's for correlations. And we've been testing it, and we wanted to show you that it works with it. Thank you. Scanning of the image happens only with its push into Artifactory, or periodically rescan images in runtime once a week when the database of vulnerability is being updated. Yes, we are scanning during the creation of the image, when we put it into Artifactory, and once every 30 days, we have a schedule like that we rescan those images with new databases. There's another one from the same viewer. Don't you try to change Artifactory to Harbor. You can build Rivi and get vulnerabilities through API. Not yet. We didn't look at it. You will have only one tool. We follow the ideology that we might have several components and they have to be scanned to cover each other. Thank you very much. Question from another viewer. Dodge defect, does it influence your work? Because sometimes it slows the command process due to performance of the product. The defect of the Dodge, it was an example how to work with vulnerabilities and analyze them and transfer them to the production of DevOps and what to do with them. It's a separate topic, and we can do a lot of Hollywood around it, so not in the framework of this answer. Do you have any defense from private zero-day vulnerabilities? Inside of this tool, no, because it uses well-known CVEs, and the scanning is done through them. This question does not detect zero-day. It can be done through other compensation materials, IPS, segmentation, etc. How the report analysis is built from the scanning of containers. On multiple occasions, I've been telling you that this process works with results of scanner, and it's a separate topic. In the framework of this presentation, we wanted to show the line through which you can evaluate how your container infrastructure contains vulnerabilities. The process of work depends on your team, on the company, on the maturity of what's inside of the company. And we can speak a separate hour about this process. Is there an influence of implementation of your scanning for the total pipeline for CI/CD time passage? I think no. It's just we're just on the stage of assembly. We take 20-30 minutes on average for the pipeline itself. And when we are in Kubernetes, we scan separately and put this image separately, so we do not influence significantly. Were you able to do the check of transitive dependencies? Well, honestly speaking, three dependencies, definitely. It can scan, but how deeply and how transitively, maybe we have not investigated. Well, yesterday we were told during presentation 3,000 can do, but it's not as good as the enterprise solution, which is tuned up for solving these objectives. Thank you.
оба сканируют на уязвимости.
TV checks both vulnerabilities. Can you check the similar results? And if yes, then how?
Сканируют, они выдают
Yes, both of them are scanning, and the result
и
on CVI methodology, and everything depends on the tool where you are going to transfer this data, because we say that we put it into JSON S3, and then we add some virtualization tool. For example, if you use Bazooka or similar CMs out there, it can be aggregated and they will not be duplicated. But if you're speaking about files into which results are being uploaded, they're not aggregated out there. So each scanner creates its own files with results. Next question, how do you process vulnerabilities when you take into account 3DD, CM, and Wazoo web?
Так понимаю, 3 UI у вас?
3 UI это в
It's 3 UIs. 3 UIs was as an example on this site, and we have tested them in 3 UIs, and it doesn't mean that 3 UIs and 3 services are used on our prem. This is just as a demonstration of the universality of this solution, that 3 tools can be used to upload this data and show it. So we work with 1 UI.
Как вы создаете таски по ошибкам разработки?
How do you create errors or tasks over declarators? Do you use Dojo or the other products? Yeah, we use Test Tracker.
не используется для передачи.
If it's a Doge defect, it's not going to be used through. It's created the corporate one.
Образы с уязвимостями уровней critical или high.
Critical or high level, are they permitted into the prod? Well, this is a question about processes. I'm not going to give you the answer to this question. Honestly speaking, the tool allows us to
Настроите. Вы можете
transfer them. It's back to CI/CD. You can have a mandatory scanning with stop factors, so it wouldn't allow if certain factors are going to trigger. Also, you can do it informative, so that image would be checked, but afterwards in the production it still goes. So it's down to your selection, how you build your processes and your team. Did you look at other ASOC systems in addition to Defect Dodge?
Defect Dojo, Xpatrial.
We've been looking at Defect Dojo, Xpatrial, CM, and Wazoo.
Не рассматривали ли возможность поделиться решением с сообществом?
Haven't you looked at the possibility of sharing this with society?
Пока не рассматривали.
Not yet.
Мы пока его разработали, тестируем, смотрим, анализируем и смотрим.
Because we've developed it, we analyze it, we check it, and we see how can we improve it. And then we will see what is to be done with it. Do you process cloud data in cloud infrastructure, personal data? It's not a topical question, but cloud providers do comply to the law 152. So it depends on which cloud you're using. You've conducted the resulting analysis of what you've got about Kaspersky container security, why your product is better than others. The Q-related feature is also there.
Есть фичи.
What are the features?
Продукта это то, что, во-первых, он поддерживает все версии Kubernetes.
If, first of all, it supports all the main versions of Kubernetes, it's not connected to it, and relatively you can repeat it on the open source technologies, you can repeat it in the cloud.
Конечно, он все фичи, которые есть.
It doesn't cover all the features which Casper has, but it solves most of the objectives, something like that. Thank you very much. And the final question, why don't you launch scanners in the CRM timer and push Effect Dodge? In CI, we do launch it, but not all the images can be assembled in CI, and Jinx is transferred from the external into the corporate Artifactory. So we have 3 stages where we scan this: CI, Artifactory, and Kubernetes.